In this video, we are going to discuss C++ functions and principles of structured programming. These are our weekly materials and handouts, and so these are the set of topics that we're going to talk about. Once you watch this video, again, I encourage you to carefully read the posted chapters in these tutorials. And there are also quizzes available in some of the tutorials that you can use for self-learning. Today's handout is called Procedural Programming, and I'm opening presentation version of it. The idea of structured programming is based on a set of actions and some data that can be manipulated by these actions. For example, in a blackjack table game, you can imagine the actions that are happening during the game, such as shuffle, deal, bet, hit, stand, and other actions. At the same time, the objects that are being manipulated could be viewed as cards, suits, decks, bank, hand, score, dealer, player, and so forth. Generally speaking, these are all sorts of data objects that participate in the game. Some of the actions are directly related to certain types of data. For instance, shuffle deck. You can see that I'm using a marker here indicating that this is a possible relationship between this action and the object or subject of this action. Likewise, deal, hand, and bet by a player. And these actions could use certain objects as their input parameters. A combination of all actions that you implement in your software and all of the data objects that support these actions is the foundation of structured programming. Typically, your application data is placed in the data segment of our program, and all of the actions, which in our case, if we're using C and C++ programming language, all of these actions will be represented by C++ functions and will be placed in a text data segment. Of course, the main function would also be present somewhere here in this text memory segment, and this main function will start calling certain functions as needed to run the entire application. The functions themselves can be calling each other, implement all the business rules, formulas, computations, and so forth as required by our application. You may be wondering, what is a non-structured programming? Well, it's the situation when originally programs were written in a low-level, machine level languages, and it would be possible then to throw all of this logic in a single text segment without any designations of functions, procedures, or actions. So basically, all the code would be just one single blob, and then it would jump from one place to another place to another place to another place. And the idea behind non-structured programming is that it creates a code or implementation which is very difficult to follow. It's hard to see the actual logic of the program. It's difficult to make changes, and it's difficult to implement new functionality. So non-structured programming sometimes is called spaghetti code because of all of these jumps that start to look like a plate of spaghetti. So basically, the typical approach to design an application is to have certain initial idea, use brainstorm sessions to decide what should be done initially. You start working on the vocabulary of your business domain, like here, certain wording that we use to name our variables and functions would correspond to the vocabulary that we are using. Then we decide on what features should be implemented in the current version of the software. Of course, we also need to think about the user interface, how the user is going to interact with the program to accomplish all of this. But the main focus of today is that in procedural programming or structured programming, which is the same thing, the building blocks of all of this, there are two fundamental building blocks, a set of variables and a set of functions. And you can see that functions do take certain parameters to implement their logic. And my general advice is that you always take an incremental, kind of slow approach to designing your programs. So basically you just do some foundational coding and start testing. You need to be able to learn how to compile your program often, and each time you make a change somewhere in your code, just recompile and quickly test. So test often, test all of the small changes that you make, and normally just make a change in one place. Don't try to make too many changes here, here, and here, thinking that everything will be working as you predicted. So it's best to just take a very disciplined and small incremental step approach to mostly just make one change and immediately test it. As you begin to gain more experience, you may speed up this process a little bit, but at the beginning, again, I would advise you not to make too many changes in too many places, and compile your program often and test it as soon as you compile.